Hello, and welcome back to Dini Teaches. Today, we will be going over the concept of vector subtraction, the process of which is quite similar to vector addition. So, how do we go about doing vector subtraction? Well, we will employ the same techniques as vector addition, which is our tip-to-tail technique. We know from our last video that if you do scalar multiplication with a vector and the scalar -1, you'll reverse the direction of the vector. So, another way to write vector subtraction is a plus the scalar -1 times vector b. Now we can do vector addition with the second vector scalar multiplied by -1. Let's see this in action. Here we have vector a, 5, 5, and vector b, 2, 4. Let's try and use tip to tail to find a plus b. Using this, we found a plus b to be 7, 9. Now, let's use these same vectors to find a minus b. We can change a minus b into a plus b times the scalar -1. To multiply b by -1 graphically, we shall reverse the direction of the vector. Then, using tip-to-tail technique, we can find a plus -1b. This resultant vector is 3, 1. Now, you may remember that vector addition is commutative. Let's test to see if vector subtraction has this same property. To do this, we'll check if b minus a is equal to a minus b. Let's do the same process. We will reverse the direction of a, use tip to tail, and our resultant vector is -3, -1. Since a minus b is 3, 1, and b minus a is -3, -1, vector subtraction is not commutative, since these two resultants are different vectors. Now, let's try some examples of vector subtraction. Using these vectors a and b, let's see if we can find a minus b using only the graph. Let's reverse the direction of b, then use tip to tail, and we can see that this new resultant vector is 3, 0. Now, let's do b minus a. We'll flip the direction of a, use tip to tail, and our resultant vector is -3, 0. Now, let's try doing vector subtraction only with numbers. Let's do x minus y. That becomes 0, 9 minus 3, 2. This becomes 0 minus 3, 9 minus 2. Then this becomes our resultant vector, -3, 7. Let's try y minus x. This becomes 3, 2 minus 0, 9. This becomes 3 minus 0, 2 minus 9. Then our resultant vector, 3, -7. Keen viewers might be noticing a pattern here. Notice how when we reverse the order of vector subtraction, the resultant vector is simply the original subtraction vector multiplied by the scalar -1. Let's simplify that with an equation. The vector subtraction resultant vector can be found by multiplying the opposite order of vector subtraction by the scalar -1. That's all for my video on scalar multiplication. I hope this was informative, and happy learning.